Hello everybody, my name is Shadi Abdullah.
Pierre Charles.
And Daily Gunner.
And we are here to present Team Grid-Eye. We are also sponsored by Northrop Grumman, and we were supervised by Dr. West and Dr. Lovell and also Dr. Kim. So I'm just going to give you a little bit of background, problem status, go through the current status of the art, design requirements, also give you a solution approach, implementation, and costs and resources, and show you how we tested everything. Okay, just a background. The project is sponsored by Northrop Grumman, and we are to produce a grid-eye sensor that detects thermal images, and we're also going to track those images by the hottest target mode. So we'll have two different modes: standard tracking mode, where it's just scanning the room, looking for temperatures, and hard target mode, where we're scanning the hottest temperature and being able to track that. After we do that, we're going to display these images on a LCD screen and show the thermal block. Okay? And that is our problem statement. I will turn it over to Daly to talk about the design requirements.
Taking a look into the design requirements, we wanted to make a system that was as small as possible. I mean, let's face it, we wanted a system that's 20 pounds. I mean, it's 20%. So we want our max weight to be 1 pound. The desired weight is 0.5 pounds. We have operational temperature of negative 15 degrees Celsius to plus or minus 4 degrees Celsius. The grid-eye sensor itself actually has a 60-degree cone of radius, so we want that to be the field of view. Ours will be supplied by a 9-volt battery. Scanning system would have a plus or minus 90-degree pan and tilt, and a plus or minus pan and tilt, and a plus or minus 90 degrees of rotation.
This is the current status of us. We've researched a couple of common types of sensors that are out there, and we've came up with these sensors. We have the passive and the forward sensors. The main feature for this sensor is temperature measurements and motion detections. And the thermal pile is which is also an 8x8 grid sensor that has the ability to measure temperature, to detect motion, and detect presence as well. And ultrasonic sensors, there are sensors we use interpret sounds and radio waves to measure motion, to detect motion. And this sensor we did not consider it because it does not fit the purpose of our project. The purpose of our project is to detect motion and measure temperature, so that was not considered for our project. And also the FLIR IR cameras, they are thermal image sensor, which detect heat signatures. But since our customer had some requirements on the type of sensor that we use, and we will use the grid-eye sensor because the grid-eye sensor measures temperature, it detects motion, it detects presence, and also provide a thermal image. This is the alternative designs we came up with. The sensor over there on the left side is an IR sensor, and this is a stepper motor that we tried to use also. We came up with almost the same solution as using the grid-eye sensor and the high-tech motors that was required by our customer to use. Also, this is the board that we used to make the connections for our components, and this is the microcontroller that we use. This is the Arduino Uno. This is the brief schematics for the stepper motor, and this is a driver right there. The stepper motor is not compatible to the Arduino, so therefore we use a driver, the UCN 5804B, to drive the motor to make it work in the system.
Okay. Because that didn't work, we had to use the grid-eye sensor and design a platform for the grid-eye sensor to pan and tilt. So we came up with the S3 pan tilt system, and what that consists of, because we had a 1 pound weight requirement, we had to isolate the components of the system and leave the extra components being the breadboard, the Arduino, the Intel Atom board, and distinguish them separately from the system. So what we did was we we have the camera and the grid eye sensor mounted onto this platform, okay, and this is external from this port right here, and we've also developed an additional platform for that, okay. So what this does is it reduces the weight requirement, and we have the grid eye sensor mounted on, and the camera, and then the Arduino board and everything connected externally, okay. And this is just quick specifications about the grid eye sensor. As we mentioned earlier, it's an 8x8 thermopiler, so 64 thermopiler elements. And this is the dimensions of the sensor. You can tell it's really, really small. And then here we have the circuit diagram for the PCB board that we mounted the grid eye sensor on it. As you can see, that there's two different circuit diagrams. The difference in these diagrams are the slave addresses. Now, the reason why this is essential is when we start coding using processing and Arduino, we need to be able to distinguish which PCB board we're using. And you can tell that there's different amount of capacitors and resistors, and the values differentiate. So that's the biggest difference. And we've also, to be able to distinguish and not have any issues with that, when we're coding, we've also been able to label ones and zeros, which signify which PCB board we'll be using. And the one, as you can see, this ends in a 0, so that's the PCB board that'll end in 0, and then this slave address ends in a 1, so that's how you know that we'll be using the 1 on the PCB board. Okay, these are Gerber files that we obtained, and as you can see, there's ones and zeros on each board to signify which slave address we used in the previous circuit diagram. Okay, as far as the design comparison, I'll take
Taking a look at both designs that we chose to go with, they are both pretty similar. The only difference that we could come up with is the sensor. The grid eye sensor detects multiple objects at one time. As the MLX only detects one. We tried to use, for the pan and tilt system, we was going to use one, but we decided that we could use two, so we kind of compared them the same. The grid eye sensor is way lighter. We should add that too. It's way lighter than the MLX, and they both have the same field of view.
All right, so solution approach?
The solution approach is roughly how the system looks once completed. This is a grid eye sensor that is connected with the Arduino, with the microcontroller and the servo as a closed loop. And since we also use the wireless communication system using XBs as ways to communicate wirelessly, to establish communication wirelessly between the Arduino and the microcomputer that we use, which is the Intel board. And this is the LCD screen on which the thermal image will be displayed, which is connected to our computer, to our microcomputer. These are specifically the tasks of each partner in the group. And for myself, Pierre Charles, I developed the alternative design for the whole system. Daily, he worked on specifically on the wireless communication part, and Shadi did the detection and tracking of objects by the sensor. But in all, we all use we all spend time with each other and integrate everything that we did personally, and also with the coding part, we all did that all together. So this is basically what.
For our test and evaluation, we did the weight with a digital scale. It ended up being actually 0.6 pounds, which is way below our weight requirement. But for the operational temperature,
I have a question here. 0.6 pounds for what? Just the tilt system and the sensor and camera?
Yeah.
Oh, you guys got it that low?
Yeah.
I thought it was going to be more.
Okay, maybe we'll put that one. This one, this good. With the operational temperature, we use Arduino code. You can actually see the thermal sensor. Each pixel has each temperature. We use the colors for the temperature. So you'll be able to see that once we do the code. I'll show you guys in demonstration. For our pan and tilt, everything we did today was pretty much coding. So pan and tilt was coding, detection of multiple objects. We pulled up the thermal image. We had Pierre and Shadi come from each direction. It was able to pick up on that, and then the graphic interface, everything shows up on the interface as planned.
Okay, cost and resources. Just give you a quick summary of how much we spent and justification on why we spent that much money on each part. For grid eye sensors, we decided to order 5, being that there could be errors with the sensors. We could accidentally fry the boards, the sensors, I'm sorry. And we just want to make room for error. So we purchased 5. The XD kit, which we used for the wireless communication, was $140, and just the S3 pan tilt system $80, and just the total budget was about $504. So in conclusion, the project was to detect thermal images and be able to track the hottest temperature. The reason why we used a grid eye sensor was this was something that was recommended to us by our sponsor, and they have conducted research far beyond the budgeting, and this is kind of what they're in the business of doing, which justifies why they use the grid eye sensor, and they asked us to do this.
Okay, we take a few questions.
Hey, your customer here has a question. Go back to the weight thing. I'm impressed because you guys told me that this thing was going to be like a pound or 2, and I was not happy. But you got it down to 0.6 pounds.
Yeah.
Is that why is that? What changed? What changed? I'm curious. Is it the pan tilt system that was the weight driver, or what was the weight driver?
Pan tilt system, the PCB board,
The PCB board,
we used surface mounted capacitors. That was one thing that we had an issue with.
Yeah.
We had to use surface mounted capacitors and resistors due to the fact that the PCB board was so small.
Yeah.
So it was actually a gift and a curse because we didn't think that deep into it in the beginning, but we realized that we could not actually connect all of the inputs and outputs that were coming from the grid eye sensor to be able to power it and be able to detect the thermal images. So we had to use things like mag wire to be able to connect it into the spot, and then just be able to conduct experiments and get data. But after that, we were able to find surface mount capacitors and resistors and order them, and then be able to mount the grid eye sensor onto the PCB board, and then put it in an oven to where everything would connect.